Welcome back. So today in this video we are going to see the architecture of microprogrammed control unit. So we are going to see the architecture of this. So everything is based on the microprogram instructions. So here we are going to see the architecture now. So we have the sequence logic here. We have the sequence logic. So here in this is used to store data in the control address register. So this is used to store data in the control address register. Okay, so this is used to store control add data in the control address register. So this control address register, it stores the address of control word where we are using. Okay, just store the control word. This control address register will store the control word. And in the sequence logic we have two inputs, that is one is ALU flag, that is arithmetic and logical operation flag, and then we have clock. This is one of the input. This is we have a clock pulse over here. So here in this we are going to have one more input, that is instruction register. So in this we have the instruction register. So this instruction register holds the next instruction to be executed. So this will send the data to the sequence logic. So this will send data to the sequence logic, and this is used to store data in the control address register. So this is used to store control word, and now the data in this control address register will be transferred to the control memory. So this control memory is having the micro operations. This control memory is having the micro operations, and in this control memory we have a read-only memory. Only we have read-only memory concept. So we can read the instruction and we can store. We can read and then we can store. That's all. Okay. So in this control memory we have the micro operations, and here this micro operations can generate the micro instructions. So it consists of micro instructions, and this is used to fetch instruction from the memory. This control memory is also used to fetch instructions from the main memory, and it evaluate the effective address and it also execute the operation specified by the instructions. So here in this architecture of microprogrammed control unit, so each computer having their own microprogrammed control unit. So each computer having their own microprogram routine. So in this control memory, from this control memory, the instructions will be transferred to the control buffer register. So also this control buffer register, we also call this as control data register. We also call this control buffer register as control data register. So it holds the micro instructions. Okay, it just holds the micro instructions, and again this buffer register connected to the sequence logic. Okay, this control buffer register will connect it to the sequence logic to fetch the next instruction. Okay, so this control buffer register will connect it back to the sequence logic to fetch the next instructions, and it also connected to the internal control signals and external control signals. Okay, so internal control signals, okay, and external control signals. Okay, so this control buffer register will connect it back to the sequence logic. Okay, and why it is connected back? Because to fetch the next instruction to be executed. Okay, so and a control word which is present there will also send to the internal control signals and external control signals. So this control buffer register will also connect it to the internal control signals and then external control signals. So here once again we'll come come back to the control memory. This control memory is having the micro instructions always, and it is having the ROM, that is read only memory concept only. It just reads the instruction and it just store the instructions, that's all. So this is used to fetch instruction from the main memory, and it evaluate the effective address, and it also execute the operation specified by the instructions, and it also return control to fetch phase for next instructions. So always in this control memory we have the micro instructions, and this micro instruction will generate the micro operations. So this control buffer register, also called the control data register, it holds the micro instructions to be executed. So each computer instruction initiates a series of micro instructions in the control memory. So here we can draw like this. So based on the address operation, so the things will be transferred to the control memory. So afterwards it will be transferring the instructions to the control word, so which consists of the micro instructions. Okay, so in this control address register, it just stores the address of control word what we required, and it just stores the data. Okay, and it specifies the address of micro instruction. It just specifies the address of micro instructions. Okay, so this is all about the architecture of microprogram control unit. Here we have the two inputs. One is arithmetic and logical unit flag, ALU flag, and then clock pulse will be there, and then we have the instruction register. So this instruction register holds the next instruction to be executed, and this sequence logic used to store data in a control address register, and this stores the address of control word, and this control word will be transferring to the control memory. So in this from this control memory, it used to transfer to the control buffer register. So this control buffer register will also connected back to the sequence logic, so to fetch the next instruction, and it also connected to the internal control signals, and then as well as this buffer register, control buffer register, will connected to the external control signals. So in this control memory, we have the read only memory concept. It stores the instructions, and it just reads the instruction and it stores the instructions. So this is used to fetch instructions from the main memory, and it evaluate the effective address, and then it just executes the operation specified by the instruction, and it return control to fetch the fetch phase for next instruction. So control word will be present here. So this control word will be transferred to the internal control signals and then external control signals over here. So in this microprogrammed control unit concept, see, each computer having their own microprogram routine. Each computer having their own microprogram routine. So this computer instruction initiates a series of micro instructions in the control memory. So this is all about the architecture of microprogrammed control unit. Thank you.